but youngsters, it sticks in their mind. So, sir, that comment also was very much true, that catch them young. Okay, and this college can definitely try that one. Thanks a lot.
Thank you, madam, for given plastic management. And thank you, sir, for empowering youth to manage ecosystems in crisis involves educating and engaging them in sustainable practices, conservation efforts, and climate resistance initiatives. Thank you once again, sir and madam. And now we would like to go for the next session. So which session is Dr. Vaishali Gogi's one, and she will talk on shaping the future, higher education, pathways in computer science, AI and data science. So madam, I would like to invite you to the stage, and now I would request Dr. M.D. Subhash Chandran to furnish the chair. And this is my request, and I would like to invite you to the stage.
It is my pleasure to introduce Dr. Vaishali G. Gogi, an accomplished academic and researcher in the field of healthcare data analytics. She holds a PhD in healthcare data analytics from Visvesvaraya Technological University and a master's degree in computer software engineering. Dr. Vaishali is skilled in MySQL, PHP and Python, bringing strong technical expertise to her teaching and research. She is currently serving as an assistant professor in the Department of Statistics and Data Science at Christ University, Bengaluru, a position she has held since July 2023. Prior to this, she worked as an assistant professor at National College, Bengaluru and at Alliance University, where she contributed nearly 8 years to academia. Her professional journey also includes significant industry experience. She served as a software engineer at TCS and as a software developer at Microsoft Technologies, strengthening her foundation in real-world technology applications. Please join me in warmly welcoming Dr. Vaishali Gogi.
Thank you, ma'am, for the great introduction. And first of all, good afternoon, all of you. I need some voices from the student side. Good afternoon. Good afternoon. Good afternoon. Yeah, still you have some energy left. So from yesterday we have been talking about chemistry, physics, and chemistry is completely far from my understanding, but still with so many sessions I could understand something from yesterday. And I'll be talking about computer science, AI and data science. Okay, so we have already seen many things have been explained, many innovations have been explained, and in the morning Dr. Ravi Shankar sir, he explained so many innovations he made, and whatever it is, somewhere I can connect each and every session with computer science and data science. So that was a question from one of you as well. I can connect each and everything with computer science, data science, and statistics. So, yeah. So why do you choose science? The first thing I was told was people are hesitant to go into science stream. They feel that I've seen people after 10th grade to take PCMB or PCMC, they hesitate a lot. And after learning for 2 years, when they go for UG, undergrads, so definitely they'll not have to want to continue because they had a tough time there, or maybe some of the subjects are difficult, and so on and so forth. There are many reasons. Okay, so when it comes to science, you can say it's a foundation for all the modern technologies. Your business, your logical thinking, engineering, medical, research, tech careers, or the job market. Everything involves science in it. Okay, so science is, many of them have spoken about science. So let me go to the computer science. So I have just divided this session into computer science, data science, and AI separately. So why do you choose computer science? So each and every sector, right from your banking, farming, transport, healthcare, or whatever it is, everything relates to your computer science, your global career opportunities, your job roles, such as if you're going as a developer, cyber security analyst, cloud engineer, creating apps, websites, systems, solve real life problems. So what I'm going to say is the scope is huge when you choose science. The scope is still huge when you choose computer science. You can make your own future when you choose data science. That's what I feel. So next slide. So why choose data science? Okay, just now we had session with sir. He projected a graph at the end, right? He projected a graph showing forest related, some data he projected. How did that graph come from? What he has done? Basically, everybody are statisticians here. So whatever the research you people have done, you are basically doing some statistics over it. So sir has taken a data set. He said he made students to collect huge number of data. How did he handle it? He said enormous amount of data was collected. How the data was handled? It was handled by data science or the data analysis techniques, or it was handled with some statistical techniques. That is what he might have done. Exclusively, he is not telling how he has done, but basically, sir has also done some statistics over it, right, sir? Yeah. Okay. So, there are different job roles available in the market. Data-driven decisions is there everywhere. You go and purchase a new suit or something from Amazon, right? You scroll it, you just search for some shirt or shoes today. So next day you will get a recommendation system, right? Have you observed it? You get a recommendation system. Similar people may also viewed it, similar to it. These recommendation systems are because you browse for certain data and that data is being taken care of in the back end, and accordingly the recommendation system is working in the back end. So each and everything you do over the internet, your net is on, you talk something, next day you will get the recommendation on your Facebook page, on your Insta page, or wherever you just open your Google, you will get the recommendation there. So that is how data works. Then the job roles, data analyst, data scientist, business intelligence analyst, or data engineer. There are many roles when it comes to data science. And as usual, it is used in business, hospital, government, agriculture, highly paid skills both in India and abroad. Okay, so your healthcare domain, your hospital domain, just to give you a clear idea, when it comes to hospital, I can tell you 4 sections in the hospital where you can apply data science, right? When it comes to number of patients visiting the hospital, there's a huge number of data generated. Different departments in the hospital maintaining, or they are dealing with different ailments. That is a different data you have, right? And different databases for the staffs or the doctors or the specializations, that's a different data you have. So the data is flushing just in one hospital. How do you handle it? So handling these data requires some techniques, handling this data requires some statistical methodologies which you are going to study as a data scientist. Not necessary if you are a chemistry student, you may ask, ma'am, I am doing BSc chemistry, how do I go about it? You can do. There is no mandate. You go take a Python course, you take a data set, work on it, you just take a crash course on Udemy as ma'am said. Okay, it's just a very nominal amount. You just pay out of it, you just take a data set, work on it, you will get the prediction. Right? So there is no prerequisites to become a data scientist. Only thing is you should have some statistical knowledge, your logical reasoning should be good, your critical thinking and problem solving techniques should be good. It doesn't require a computer science degree at all. Right? Now, why choose AI? AI powers your phones, banking, farming, smart cities, both are interconnected. Fast growing technological field. AI has these many roles: AI engineer, ML engineer, robotics, help solve real world problems. Okay? So now the myth is like AI is replacing the job market. How many of you agree? Raise your hands. AI replaces job market. AI ಇಂದ ಕೆಲಸ ಸಿಗ್ತಾ ಇಲ್ಲ, ನಮ್ಮ ಕೆಲಸನೆಲ್ಲ ಮಷೀನೇ ಮಾಡ್ತಾ ಇದೆ, ನಮಗಿನ್ ಕೆಲಸ ಇಲ್ಲ. ಎಷ್ಟು ಜನಕ್ಕೆ ಅನ್ಸುತ್ತೆ ಈ ಥರ? ಯಾರಿಗೂ ಅನ್ಸಲ್ಲ? ಅನ್ಸಲ್ಲ ಅಂದರೆ ಯಾಕೆ ಅಂತ ಕೇಳ್ತೇನೆ ಈಗ. If you raise your hands, you are in a safer side. If you don't raise, then I'll ask you why. Yes, some conclusion. Artificial intelligence ಇಂದ ನಮಗೆ ಕೆಲಸ ಸಿಗಲ್ಲ ಮುಂದೆ ಅಂತ ಯಾರಿಗನ್ಸುತ್ತೆ? Nobody? Ogli, at least have you thought about this someday? Technology is advancing, so our job market demand go down. No, nothing like that happens. Actually, whenever the AI comes into picture, only thing that is affecting as of now in market is your call center jobs, your BPO jobs, all those low level of jobs. I don't say low level, all those basic level of jobs which AI can take over without much risk is being replaced. AI still exists, people still exist. As the technology advances, we need people to handle it. We need people to handle the data. We need people to improvise the system. It's not like AI cannot replace any of the human beings until and unless you stay updated to the market. Today I'm learning some technology. I'm sitting with this for next 2 years, definitely it doesn't work. You update, you upgrade yourself as per the market demand. Definitely your jobs will be safer. So next slide. Okay, some real world examples. YouTube recommendation, it uses AI, right? You will be surfing through certain set of old Hindi songs, old Kannada songs. Immediately you will get some other set of recommendations over there. And Google Map traffic prediction. Me being a Bangalorean, definitely every now and then I get it, congestion here, congestion there. Every now and then I'll get it in my Google Maps. Online payment, there is security, cyber security, crop prediction and irrigation. There are many companies in Bangalore who are agriculture based companies who work with data science. There are many companies. There's a company called Cropping Technologies where we visited recently for the industrial visit. So what they do is they use this clustering algorithms. Clustering, when I say, you group a similar set of people. For example, your BCA, your chemistry, I cluster chemistry, I call it this is one cluster. I group BCA, I call it this is one more cluster. So based on the clustering or the area of importance, these cropping technologies, what they do is, they go and check where is the barren land, what kind of crop is grown there, and just they go through the data of the soil quality there, and based on that they are giving certain predictions. But the company completely works on statistics and data science. So, but the data what they are taking is the agriculture data. Yes, sir. Yes, sir. Maybe, sir. We just visited for one time. That's it. But it's good. No, sir. It's in Kormangla. Cropping Technologies. Yeah. And yeah. So online payment, weather forecasting. Naade male barutte, nadid male barutte. So heavy rains, temperature, everything. That is your AI or data science. So why you require statistics? The statistics that should inspire you in taking up science or computer science or data science. So 70% of future jobs will depend on STEM, we call it as science, technology, engineering and mathematics skills. So it requires all those 4 skills, we call it as STEM skills, and AI industry is expected to reach 17B by 2027. That is $17 billion by 2027. Data science jobs have grown 650% since 2015. So software developers among top 3 highest demand jobs, and then 1.2 million plus IT jobs expected in next 5 years. Of course, layoffs are happening now, but still it's not the end. It's not the end. Definitely some new technologies comes in, some new requirement comes in, and new data scientist or whatever it is, new role emerges. That is how the market is. Ma'am, next slide. So this is some rough statistics taken from industry projections 2024 to 2023. It is taken from a research paper. So AI and machine learning, the job growth in AI and machine learning job growth in data science, cyber security, software developer, and the average occupation is very, very less. Most of the people are opting for these kind of job roles. Whatever your discipline is, whether it is chemistry, physics, mathematics, whatever you are into, even into biology. So job market is growing in AI. So next. So real world impact, healthcare, smart cities, space technologies. So when it comes to healthcare, my research was also interdisciplinary. I am a computer science student, MCA graduate, but what I took was healthcare and data mining. So that was a liver-related disease. In order to predict the early detection of the liver disease, I had collected the data from an oncology center. And then I've given certain predictions wherein some variables I have identified wherein you can identify the disease at the stage 2 or stage 3 instead of identifying at stage 4. So that was research. So next slide. Okay. So conference theme is on innovation and science and technology. So we have to talk something about innovation. So engine of innovation, turning ideas into reality. It's just about learning. It's about inventing. So CS and AI empower you to challenge the status. You can challenge, you can go with the new challenges. And then entrepreneurship, definitely we have a good entrepreneur here who spoke in the morning. So many things he has done. You should have that skills. You should have that, okay, I'll go ahead with it and I'll bring my own product. Okay, and then global impact, definitely if you are an innovator, you will have the global impact. Ma'am spoke about patent. Okay, if you are coming up with a unique product, if you are coming up with a unique research, ಏನಾದ್ರು ಒಂದು ಹೊಸದಾಗಿ unique ಆಗಿ invent ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ, definitely it will be patented. It's like a copyright kind of a thing. Yeah. Okay, so conference is about physics, chemistry, mathematics. So everything I have related to my field. So since it was the last session. So where chemistry uses data science. Drug discovery, pharmaceutical companies run lakhs of chemical simulations. Data science predicts which chemical compounds can become medicine. So saves years of lab work. The second thing, chemical reaction prediction. Machine learning models predict how fast a reaction will happen. You don't have to worry when I take the term machine learning models. It is just a simple computer programming coding where we do in order to infer some inputs. And helps create safer industrial process, spectroscopy and chromatography analysis, instruments like nuclear magnetic resonance, infrared spectrography, all these machines, they generate huge amount of data. So definitely we need data science and statistics to handle this. Environmental chemistry, pollution data, water quality, soil contamination. Sir spoke about water crisis yesterday also, and sir also spoke about many environmental issues. So definitely there is a data. Where there is a data, we are here. That's all. So simple real world example, when you test water quality in a village, pH, turbidity, minerals, data science helps compare the results. It detects the patterns and predicts the contamination. Okay, so compare, when I say pattern is nothing but the way, for example, you have Amazon, a particular product has been launched by Amazon. So they do the data analysis for a month. They do this data analysis for a month. Okay, Amazon, we have launched our own product. Let us see how many of them have purchased it, how many of the age group of students have purchased it, or age group of people have purchased it, what is the gender, all those things, they just go through the details of it. So they will get a pattern. Pattern is nothing but it's a graph. ಅಂದರೆ ಎಷ್ಟು ಜನ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಡಕ್ಟ್ನ ಪರ್ಚೇಸ್ ಮಾಡಿದ್ದಾರೆ, ಅವ್ರ ಏಜ್ ಗ್ರೂಪ್ ಏನು, ಅವರು 20-30 ಇಯರ್ಸ್ ಒಳಗಿದ್ದಾರೋ ಅಥವಾ ಸೀನಿಯರ್ ಸಿಟಿಸನ್ಸು ಅಥವಾ ಸ್ಟೂಡೆಂಟ್ಸು ಅವ್ರ ಆಕ್ಯುಪೇಷನ್ ಏನು. ಸೊ ಯು ಗೆಟ್ ಲಾಟ್ ಆಫ್ ಡೇಟಾ ವಿತ್ ಜಸ್ಟ್ ದಿಸ್ 1 month analysis. This we call it as pattern of purchase. So based on that I can make decisions. Okay, youngsters are using more of my product, let me improvise, let me add on more feature to it so that my business improves, right? That is the inference out of it. Okay, physics and statistics and data science. It explains real world. Data science captures patterns in the real world. So where physics uses data science, astronomy and space science, definitely lot of images, lot of data will be there in astronomy and space science. Weather prediction, you use machine learning models and many other data science models for this. And then motion and sensor data. Definitely there are many simulation data that is being generated. Simulation is a different field wherein you can use many machine learning algorithms and infer the outcome out of it. Quantum computing, it is powered by algorithms and data modeling again. It's a huge topic, so I cannot go in depth with all those things. A real world example, a fan rotating, a bike moving, or a cricket ball swinging. So all generated data about speed and motion, which data science uses for prediction. Right? So next slide. Next slide. Sir, next slide. So mathematics, this you can say it's a heart of statistics and data science. Once you know mathematics, definitely you can solve any of the statistical problems here. So algebra, when I say machine learning models, linear equations create models like linear regression. And calculus, your deep learning neural networks. I'll just give you an example what is deep learning. Deep learning is nothing but when you have to deal with the data that is image related or a huge amount of data, when you train a computer system to work as human being, that is your deep learning. Deep learning is nothing but you train the system to work as the human brain. That is deep learning. And probability, decision making, weather forecasting, risk management, predictions, all those things includes your data science, vectors and matrices, image processing. So whenever you give an image, for example, you give an image of a cat. So how do the machine understand it's an image? So what it does, it plots it in the form of a pixel, in the form of a matrix, and based on the pattern it will identify, okay, it is a cat, right? So robotics, definitely it involves data science. So when your YouTube recommends videos or Google Maps finds the shortest route, it's all matrices, vectors and probability. All the recommendation systems are based on this mathematics. So bringing all together, all the three and merging into my field, data science and statistics. So healthcare and medicine, it involves, when I say chemistry, drug molecules, physics, imaging, X-ray and MRI, maths or statistics, it's predictive models, data science, discovering new medicines faster. So climate change and agriculture, physics, climate and weather, chemistry, soil and water analysis, math, modeling the data, data science, predicting rainfall and crop yield. Engineering and industry, physics, your sensors, your machines, not limited to, there are many things, I have just given two. Chemistry, materials and fuels, math, optimization, when it comes to data science, efficiency improvement and automation. Okay, so this is just a code for you people. If you choose science, you learn how the world works. If you choose computer science, you learn how to build tools. If you choose data science, you learn how to change the future. It's as simple as that, right? You should have a clear idea, what am I choosing, what am I going to do, what is my focus, and what exactly is helpful for me for my in fetching job or whatever it is. Yes. Okay, so this is some statistics. So 78% of organizations now use AI in 2024 and 109.1 billion in US private AI investment in 2024 with generative AI. And then curriculum is shifting from theory based to the learner centric base. In our university we follow something called as learner centric approach or LCA, wherein a whole class is divided into two sections and two faculty will be handling the same section but with the different batches. So what we do, we come into a common understanding regarding the assessment or whatever it is. When I say learner centric approach, it's not pedagogy, it's andragogy and it is for adults. So 50% will be the faculty contribution, 50% will be the student contribution. So based on the subjects, I think BCA students are here, right? So based on the subject, for example, your web technology, what happens, you cannot write the theory paper for that. So what we do, based on the subject, 50% we give the input, 50% you will be interacting with us. So that is some of the approach that will be shifted. Even curriculum shift happens because of AI. Alternative credential raising, micro-credentials, certificates, boot camps, and greater employer education environment, skill portfolios, industry connects. So all these will lead to the tech education revolution. So next slide. So global education landscape, this is just a statistics which I have given. So next slide. So yeah, so here are certain pathways. Computer science, it's blurry, I'm sorry. Computer science focus areas are algorithms, data structures, software engineering, and distributed computations, computer networks. When it comes to artificial network, machine learning, deep learning, neural network, computer vision, reinforced learning, and data science is statistics and probability, data mining and cleaning, ML in data analytics, visualization. And career outcomes, when you choose computer science, it's software engineer, system analyst, DevOps engineer, security engineer, database administrator. So when you choose AI, it is ML engineer, AI research scientist, AI product manager, and AI ethos officer, ethics officer. And then career outcomes for data science, data scientist, engineer, business analyst, analytics manager, many things are there. So next slide. Yeah. So degree options, if you want to pursue a degree, BSc Computer Science, MSc Computer Science, MSc, PhD in Computer Science, or you can go for abroad. Degree options for AI, you have AI graduate degree, you have certifications degree, MSc AI ML you have, BSc AI ML you have. Engineering also have a separate AI degree nowadays. And then degree options for data science, BSc, MSc or PhD, you can either choose data science and statistics or data science and mathematics, or any of the combination you are interested in. And then interdisciplinary programs are also there. When you say business analyst, it involves both commerce and the data science. So, okay, so this is one of the thought you should keep in mind. Suppose you are given a task. Suppose you are given a project or something. What is the first thing you should have in your mind? First thing, or the three things I'll tell you that you have to keep in your mind whenever you're doing a project or a research work, whatever it is. The first thing is you have to make your product reusable. Okay, so you have to make your product reusable. When I say reusable, I just ask you to come up with a software, develop a software for a particular client wherein he needs a e-learning domain or he needs a hospital management, whatever it is. Okay, so your college management system, say I ask you to develop a software for the college management system. So you come, you take the data, you develop the software, everything is fine. Now what happens, your college comes up with a new department. What you will do? You have the project ready. You are about to release it. Your principal says a new department is coming in. So these are the things, credentials, and these are the faculties you need to add to your project. What do? You should design your project in such a way that even if such extra thing comes, it has to be reusable, it has to be scalable. Your project has to be extendable. Whatever the work you are done, even if a new requirements comes, you should have that space in your work so that you can add that department in your project. That is called scalability, right? That is called scalability. Now, you are done with your project, it is scalable, you can expand it, it is okay in all the respect. Now, one more college comes, they'll say, okay, I know that you have a project already, your students have done, please give the project to us, we will pay you money, right? Please give the product to us, we will pay you money. So, can you give it as it is? So, what is your responsibility? It has to be reusable. You cannot design your project for your spouse specific motive or for a specific college. So it has to be in such a way that even if you give that module to some other college, with little changes of course, with little changes in UI or whatever it is, but it has to be reusable. You should not again sit and develop the same thing again and again. Your modules or whatever you are developing should be reusable. And the third, the most important thing, it has to be unique, right? I give a problem statement. I'll give, for example, Sir gives a data set. Okay, so he'll say, you come up with some solutions for this. He gives some problem to you. I will give to 10 students. All 10 students will come up with a solution. But I check who has come up with a unique solution. All 10 solutions are correct. I'm not telling solutions are wrong. But whoever is coming up with the right, unique way, I'll accept it. That is how all the companies recruit people as well. Nowadays, wherever you go, they give the same problem statement to all the candidates over there, and whoever comes with a unique solution will be considered for the job. So that is why I tell you, being the, just previous slide. So being the best will make you number one, of course, but being unique will make you only one. Okay? Yeah. Thank you. Any questions?
Thank you, madam, for pursuing higher education in computer science, AI, and data science, and equips students with in-demand skills like machine learning, cloud computing, and data analysis, open doors, high growth careers in tech and healthcare and finance and more. And thank you very much, madam, for giving an insightful talk. And sir, I would like to invite you to conclude this session.
Really, what Dr. Vaishali Gogi has given a wonderful picture of artificial intelligence coming into every field, and in fact it is beyond something beyond my imagination, because it will, she anyway reassured that it will not replace the human brain and intelligence, but reading Aldous Huxley's Brave New World and Brave New World Revisited in 1930s written books, I find now the scenario is unfurling now. The Brave New World is already at our doorsteps. Now the people may be created in laboratories, and there will be new caste systems like alpha people, beta people, like that, different grades. There will be alpha people will be all geniuses and who are of that kind, and they will be controlling all the manpower. But some tyrants will be at the top, the political people, and they will be chained by those tyrants, the politicians, and they will get the work done through artificial intelligence. This is predicted in 1931, 1930s by Aldous Huxley. Two novels are there, Brave New World and Brave New World Revisited, and how the marriage also becomes an obsolete custom, marriage. So there is nothing sanctity about marriage. You can go to a supermarket and in the what kind of genetic composition the child should have, that you can choose, and then they will grow according to your demand. The artificially fertilized, genetically engineered ovum into the kind of individual what you want. And also even monsters can be created by criminals using such artificial intelligence for manipulating, and see that people very mechanically acting without, they will be put for very manual jobs where they do not think, and they will be in the evening, they will be given all kinds of entertainment, and their world will end. So this scenario is to some extent coming true and takes away the human brain, but to create that human brain, what kind of brains are required to create this controlling factor for human brain like artificial intelligence. So such are the geniuses what we find. Maybe the human figure also will become very, very, very minimal, human figures also. But the brain will be dictating. Understand? So Dr. Vaishali Gogi has now given very pleasant picture. I don't know how future is going to emerge, but all of us have to think, all of us should know artificial intelligence and how to use it for the advancement of our economy and also ecology, like that, for growing and not for exploitation. Okay, it was a nice opportunity for me. Thank you so much. Thank you for a very
Thank you, sir.
illuminating
It's
talk.
an honor to be chaired by you. Thank you so much.
Thank you, madam, and thank you, sir, for your great conclusion with great remarks. And now I would like to invite Dr. Yoshiro Azuma. So very enthusiastic and a very active person. So for his session, I would like to invite Dr. Petnev as a resource person. And I would like to invite you, sir. So your talk is on atomic and molecular physics with synchrotron radiation, tabletop experiments with big facilities.
It is my privilege to introduce our distinguished speaker, Dr. Yoshiro Azuma. Dr. Azuma holds an MS and PhD in physics from the University of Oregon. Over the years, he has served in several renowned institutions, including the University of Oregon, the University of British Columbia, and Argonne National Laboratory, the Institute of Material Structure Science, the Graduate University of Advanced Studies, Sophia University, and IIT Delhi. He is currently a full-time visiting professor in the Department of Physics at BITS Pilani, Goa campus. His research interests span atomic and molecular physics with a focus on photoionization studies, science education, international education, the history of science and the role of science in society. He has supervised eight postdoctoral researchers and has been awarded several competitive research grants, including the JSPS NSF Japan US collaboration, the Matso Foundation grant, multiple JSPS grants in aid, and the grants from the Ministry of Education. Please join me in warmly welcoming Dr. Yoshiro Azuma.
Well, thank you very much for the nice introduction. So I'm Yoshiro Azuma from BITS Institute of Technology and Science, Pilani, Goa campus. And I also have, still have a kind of formality, but appointment with Sophia University back in Japan. Just a moment, let me get my laser pointer. Yeah. So this is BITS Goa. Well, I think in the interest of time, we'll kind of skip through. This is Sophia University. It's the Catholic University of Japan, and it's in, as you can see, the center of city Tokyo, right next to the Imperial Palace. So it's as close to the center of Tokyo as it gets. It's quite a different setting compared to the nice pastoral rural atmosphere here. This is another picture of it. And well, now that I'm showing pictures, I would like to show you the picture of the advanced photon source, the synchrotron radiation facility at Argonne National Lab, where I used to work when I was younger. And this is where I became much interested in synchrotron radiation. a topic that Professor Petnev also discussed yesterday. So what is a synchrotron radiation facility? Maybe you can get a hand mic to me as well. Yeah, hand mic, yes, if it's available. The synchrotron radiation facility is something that will look just like that, And you know what goes on inside there? As Dr. Petnev explained, electron bunches are going around the ring at a speed very close to the speed of light. And it's emitting really strong radiation in the tangential direction. And what do we do with this light? We irradiate various experiments or sample that, for instance, somebody like myself will bring from my university. So that's my small experiment combined with this big facility. That's why I have in my title the big science combined with small science kind of concept. Yeah. Okay, and so what does it look like inside the ring? It has this ring with high energy electrons going around, and then they have these, what's called these beam lines emanating tangentially from the ring, and then my apparatus. Oh, it says atomic and molecular science, right? Maybe the print is too small, but this is where, at the end of these beamline, where I put my own experiment and irradiated with synchrotron radiation. Okay, and this is another synchrotron facility on the beautiful, oh, there it is. Oh, hello. I kind of like to run around and walk around, so this is kind of handy, yeah. And does it sound all right? Yes. Oh, in the beautiful foot of Mount Scuba in rural southern Ibaraki lies a big national lab where my synchrotron radiation facility was. And a somewhat newer facility, this is Spring 8, 8 GeV, very large facility where I did my later experiments in Harima, Japan. And you can see this long thing extending out. This is not exactly a beamline, but this is a free electron laser. Yeah, Professor Petnev also talked about it. And why is it here? It's so that you can do experiments merging synchrotron beam together with free electron laser beams. Yeah, so Japan has a lot of world-class facilities like that. And of course, India also has one. This Indus 2 in Indore, India, at Raja Ramana Center for Advanced Technology under DAE, Department of Atomic Energy. This is a first-rate synchrotron facility which is now in operation and, well, has been in operation, and now there's an even larger Indus 3 facility being constructed. Okay, you guys can do experiments here. However, I cannot, okay? I was quite disappointed. This is something I was quite disappointed. This is a Department of Atomic and Energy facility, so foreigners are not allowed here. I went there, but I couldn't even take photos, and I cannot do experiments here. You guys can, and well, there are many issues I have with the science administration in particular, and experiments, not so much about theory, but in experimental sciences. And I always feel, yeah, young people are better than old people. That I am convinced about. You guys are better. The young people here, I'm telling you, you guys are better than all of these older professors who gave talks yesterday and today. Yeah, I'm convinced about that, but that is only if you work hard at it. Please do so. And please get a job, for instance, at a place like Indus2. You already can, yes. And yeah, improve the situation for me. Yeah, why don't you do that? Well, after getting your bachelor's degree, you can get a job, look for advertisement and things, as a technician, yeah, helping the maintenance and operation of the beam lines and facility. Or if you go on a little more ambitious, you go on, get a master's degree, and then you can get actually participate in building machines or designing improved beam lines and all sorts of a little more creative work. Oh, why don't you get even more ambitious and get a PhD, and you can actually plan and design facilities and do research experiments utilizing this kind of facilities like I did. Okay, so we're talking about synchrotron radiation. I haven't said anything about the principle about it. I would like to show you simulation about the principle by my good friend. Let's escape from this for the time being. I cannot do that, can I? Okay. Just one moment. Okay. I think I screwed up something here.
Full screen.
Well, this is full screen, but
Try to drag your video to the right or to the left.
just one moment. I think I'm still somehow in the presentation mode. So, well, why don't I just get out of this?
Escape.
Escape, right? Escape, and I am out. Oh, thank you very much. Okay, yeah, thanks. And let's take a look at Shintake's, not this one. Yeah, simulation. Yeah, look at this. Look at this. Ah. Have you seen anything like this? Have you ever seen this before? What do you think this is? What is this? My young friends, what is this? Maybe you have seen something like this on your textbook. Have you? What is this thing? What is this thing at the center? Or what do you want this thing to be? Well, huh? What? Speak up. What did you say this actually, you never know, but what do you think it might be? Huh? Radiation, yeah. It's, well, and at the center of it, there's an electric charge, right? You have probably seen a figure like this on your textbook. And the lines emerging from that, that's called, yeah, electric field lines, right? Uh-huh. So, what do you think will happen if you wiggle the charge? Oh, let me actually try it. Oh, look at this. Look at this. What came out? What do you think came out? That is light, electromagnetic radiation that comes around. In the field line picture, it forms as wiggles on the field line. Okay, let's put this on automatic mode. Yeah. let's make it oscillate. And I don't have to, well, wiggle it with my hand. This is called dipole radiation, coming out from the dipole oscillation of the charge. Okay? Very good. And you can put it on a circular trajectory as well. Okay. Oh, well, I made a mistake. I wasn't going to show this right away. Well, okay, I seem to have a bit of a problem. I was going to show you normal radiation, but this is what? This is synchrotron radiation, okay, coming out from a circular orbit. Synchrotron radiation happens when you have your orbiting electrons are really, really very fast and energetic. It changes its character from ordinary dipole operation. And let me show you how that works, okay? Let's just get rid of it. And we come back to, not this one, but we come back to, yes. Actually, I will leave this on this rather than presentation mode, just simply on my screen, since it's hard to go back and forth. Okay, what is synchrotron radiation? It's a kind of relativistic shock wave. Okay, do you know what shock waves are? Yeah, you probably have experienced it. Yeah. Fighter plane, fighter jet, supersonic airplane comes at you, okay? Comes at you. Do you hear anything? I suppose you don't hear anything. And once it goes over your head, it's going to say, bang! And then it goes, something like that, right? I'm sure many of you have experienced. That's called, that's a shock wave, acoustic shock wave, classical acoustic shock wave. It happens because, yeah, the aircraft is emitting sound waves all the time, big sound waves all the time. But if your aircraft speeds up fast, okay, then the sound wave cannot get ahead of it because the airplane is so fast. As a result, it accumulates in front of the aircraft and then and forms a very sharp wavefront with waves accumulated on top of each other. And at supersonic speed, it kind of makes a conical wavefront, like what you see to the right, okay? And then you have this, in the case of synchrotron radiation, the electron bunches are so fast, sorry, so fast that that you now have to consider relativistic effects. You probably know that your aircraft can really not go faster than the speed of light, okay? In synchrotron radiation, the facility, the electron bunches goes much faster than the speed of sound, very close to the speed of light, okay? So there's a lot accumulating, but the source doesn't really fly past it. It just accumulates and accumulates and accumulates there. And there's something called relativistic contraction. The whole whole thing, the lengthwise becomes narrower and narrower. That means more waves, I mean per linear density, more and more waves because of relativistic contraction seen from us. And that means more waves, but also shorter wavelength, meaning higher energy. You know something? In quantum mechanics, shorter wavelengths means higher energy. So you get an extreme concentration of high energy radiation. And that's how synchrotron radiation facilities work, yes. And so I said I put my experimental facility like this, yeah. This one right here, can you see it? Well, I said tabletop experiment, but well, it's as big as this one. This one in particular is my electron analyzer. What does it do? You are photoionizing, I mean irradiating atoms and molecules, in my case, with this powerful synchrotron radiation, and looking at the electrons that are kicked out from the atoms and molecules, okay? That I measure with this apparatus that I bring to the synchrotron radiation facility from my university, okay? And so what are we doing to the atoms and molecules? Oh, according to quantum mechanics, yeah, the energy, the internal energy of the atoms and molecules can't just take any values. They have discrete quantized energy levels that it can take, okay? And that is because of, well, in terms of wave mechanics, quite similar to how the harmonics works on your guitar or on your vina, okay? Only if you have a certain string and pluck it, you get not all sound frequencies, but only certain harmonics, right? In a manner very similar to that, you have energy levels. Okay, again, frequency relates to energy. This is a really interesting point about quantum mechanics that you may not have studied yet, but I hope you will in the not so far future. Yeah. And there's another thing that's very interesting. Light. I said higher frequency light is higher energy, right? Higher frequency photons. The photon acts like a particle, and it's a clump of energy too, and its energy is proportional to nu, the frequency of this oscillation. Yeah. So yeah, if you put in the right amount of energy, yeah, the fixed frequency photons may come out, or fixed frequency photons may go in, and vice versa. And you can examine these photon energies in order to study the patterns or the characters of these energy levels, okay? That is called spectroscopy, okay? Spectroscopy, that's a word invented actually by Sir Isaac Newton. Spectra means to see, and scope, well, scopy is scope, yeah. To see the, what's in the wavelength distribution of the light, yeah. Okay, so you do these spectroscopy experiments with this high energy synchrotron radiation. And well, I would like to show you another simulation. This one was the FET simulation initiated by my friend Carl Wyman, who happens to be a Nobel laureate. And it has many components in it. I will show you the models of hydrogen atom. This is their HTTPS location. if you're interested, well, I suppose you can take pictures, okay? And let me just show you, where did it go? Where did it go? Oh yeah, this is a good one. Oh, look at this. These are the orbits of the electron that goes around the nucleus, okay, in an atom. And these orbits, discrete orbits, actually correspond to certain discrete energies, as I told you. And the principle of, actually, I think you can have a better view with, how about a side view, board, Roy? Spectrometer, monochromatic transitions. Okay, I can't exactly locate it. Oh, okay, this is the, yeah?
5 minutes.
5 minutes, okay, these are the energy levels associated with it, and let's shine it with photons. Oh, and look at that. It shows you how, depending on different color or different energy of the photon, it goes up from a certain level and then comes down to another level. Actually, with very high energy photons, you can actually blow away the electrons in the energy instead of going to a bound state, and that's called photoionization. Okay, well, it's not much time left, so actually, we like to say a few things about my research as well. So let me just explain to you an interesting phenomenon called Auger process, okay? You can photoionize, I mean kick out an electron from deep inside the atom, okay? Inner shell, that's called inner shell photoionization. What's going to happen after that? What will happen, do you think? It's not too hard, probably not too hard to guess that an outer electron will jump into the hole that was left by the photoelectron that got kicked out, okay? In that process, it may emit another photon, or maybe instead of emitting another photon, it'll kick out another outer shell electron. This outer shell electron can get kicked out instead of a photon transition being made inside the atom. And this is called an Auger process. And the electron that got kicked out is called the Auger electron. So what do you have? You have electrons being kicked out, and then Auger process happening, and another electron going out. Okay, this is called an Auger process, and I study some interesting details about this. Okay, so yeah, an electron goes out, and then, well, this electron, you can make it go out very slowly, okay? So then an Auger electron goes out. This Auger electron is actually quite fast and energetic. So on the way it's out, it's going to interact, right, with the first electron. What's going to happen if they interact? Okay, well, somebody told me that, some student told me that it hits the Auger hits the photoelectron from behind. So the photoelectron may speed up and the Auger may slow down. Okay, yeah, that's one way of looking at it in a classical picture, but what actually happens is quite different. Well, that kind of process actually happens with a small probability, or what you call amplitude, but more generally, well, this is quantum mechanics. The photoelectron is kind of emanating out in all sorts of directions as a cloud. And then the Auger electron is also emanating out in all sorts of directions as a cloud. So they kind of just go through each other, okay? Just go through each other. So Auger electrons go through the photoelectrons. Oh, what happens next? Then the first electron suddenly sees an increase in the inner charge. It looks like there's more inner charge, right? So what's going to happen is the photoelectrons get drawn back, and because of the pull from the nucleus, and the OJ electron goes faster. Okay, that phenomenon is called post-collision effect for various historical reasons, actually. We don't see a collision, but it's called post-collision effect. Okay, and that's what I study. And I study these photoelectron energies and OJ electron energies shifting and moving and all that kind of things. And I just told you that the photoelectron gets slowed down. In some cases, it can slow down enough that it starts going back to the atom that it left and gets recaptured into a high-lying orbit of the atom. And that's called photoelectron recapture. And then you see, well, this is kind of a superposition of two types of process. This is an OJ electron line. But when you make the photoelectron slower and slower, it develops substructure reflecting this recapture into high-lying orbitals. So that's narrow type. The narrow speaks the high-lying orbitals kind of overlapping and also together making this OJ, this faster electron energy profile. Okay, this is the kind of things that were discussed by my friend Axela around the time when it was discovered in the 90s. And more recently, my group manages to get a much better spectrum that looks like this. Okay, I don't have much time, so I should show you another very interesting case. So I said photoelectrons go out. First electron goes out, and then another electron goes out. That's the OJ electron. And if these all happen in a deep inner shell, maybe there will be a few holes left in the atom. And then, of course, successive OJ processes are going to keep happening in the rest of the atom, and electrons keep going out. Oh, so what happens? You photoionize a deep inner shell electron, and then it keeps going through steps of these OJ process, spitting out electrons and ionizing itself, okay? This is called OJ cascade. And an interesting case is here when this black line, this is the photoelectron going out. This green line, this is the OJ electron going out and interacting with the photoelectron. And then the red line, the second OJ electron goes out and interacts with the photoelectron again. Okay, what you're seeing is that these two green and red OJ electrons, they don't interact with each other directly, but they interact through interactions with the black photoelectron. Isn't that interesting? Isn't that kind of, well, I think time is over, but yeah, is sequential double capture. That's kind of, that's like a pool, isn't it? Yeah, one hitting the other and then the other hitting the first photoelectron. It's like pool or billiard. So this is kind of like a electron quantum billiard. Okay, these atomic nuclear particle experiments are done all in the context of single collision, okay? And, but we, in our experiments, see sequential collision that are not really seen in any of these particle experiments. And this is very interesting. Well, I hope, I'm afraid I don't have the time to highlight in what way it's really interesting, but they are very interesting. At least I can tell you understand that it's something that's never done before. And well, and these all processes also happen very fast. So from the manner we observe them, time delay between this photoelectron of the OJ electron is of the order of 100 attosecond. So we can analyze processes that are like 10 to the minus 16th second, which is 0.00000 blah, 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 1 second, okay? And this is at least as good or somewhat better than some ultra-fast science experiments pursued by short pulse lasers. Okay, so I'm afraid I overrun by a few minutes, but yeah, this is the kind of things, the electron billiard, pool, or snooker that I enjoy with these kind of experiments. And well, thank you very much. And Daniel something, yeah, thank you.
ಧನ್ಯವಾದಗಳು ಸರ್. Thank you so much for sharing your insights on atomic and molecular physics with synchronization radiation. Your expertise has made the session both enlightening and engaging, and we truly appreciate the time and effort you have put into the discussion. So it's been a pleasure having you, and we look forward to future conversations. Thank you, sir. And now I would like to invite Dr. Petnev to conclude this session.
I guess I will be only short. I would like to thank Professor Azuma for his introduction to synchrotron radiation. Indeed, I was playing myself with this software some 15 years, not 15, maybe 10 years ago. I also recommend you to download this software and see how you can generate radiation yourself. It's pretty much realistic, right? As well, here we met two worlds. Experience from usage of synchrotron radiation and a person like me who is from machine physics. And I'm very happy to be here with him today. And I'm very much happy that he also joined us in BITS Pilani, and he gives us his inspirations and experience in BITS Pilani also to the students there and to you as well. So be curious in future, grow up, world is big, you can learn a lot of things, right? And we are here to help you. That's it. I would not delay you much more. We have one more talk. So please attend. Thank you.
Thank you. Thank you very much, sir. Thank you, both of you again. And before that, I would like to announce one thing. So if anybody's paper, especially students' papers, is not yet presented, please go to the seminar hall and present your paper first. And now I will invite Tejas N. Kulkarni, so who is studying in second year BE in BITS Pilani, Goa, and who will talk on measurement of delayed luminescence in plants. This is the time of yours, and please go through this.